In this lecture, we're going to talk about reactions of polymers. Once you've formed a polymer, the polymer itself can react, as shown here. You can see that vinyl acetate is polymerizing using benzoyl peroxide and heat to form polyvinyl acetate. Then polyvinyl acetate undergoes a hydrolysis or saponification reaction to form polyvinyl alcohol. This is useful synthetically because it's hard to make polyvinyl alcohol another way. The monomer that polyvinyl alcohol comes from would be this. This is vinyl alcohol. And if you think about what vinyl alcohol is, technically it's the enol form. And so it would exist primarily in the keto form. And if it exists primarily in the keto form, you're going to have a really hard time polymerizing vinyl alcohol. So we need to go through this process where we react vinyl acetate and then do the saponification. Now the reaction of vinyl acetate to polyvinyl acetate, that's under a radical mechanism. Benzoyl peroxide would cleave at the oxygen-oxygen bond and then get a radical chain starting that would react with the alkene. And down here in our saponification reaction, methoxide is going to attack the carbonyl carbon and push electrons up onto the oxygen. The intermediate that you get, and I'm not going to draw out the whole thing here, but it continues to react. The electrons come down, kick out the oxygen, and the resulting negative charge is protonated to get to the alcohol. Another example of a reaction of polymers is in the vulcanization of rubber. A natural rubber is shown here. And if you wanted to, you could add sulfur as a cross-linking agent to link the polymer chains together, and that would give you a disulfide bond. And this is called vulcanized rubber. Vulcanized rubber is the type of rubber that's typically used to make tires. So polymers are typically linear, and when they're linear like this, you can see that they can coil randomly in all sorts of different ways. They can also branch sometimes, where you have a main chain and you have little branches coming off the main polymer chain. Or we can do cross-linking, like we just talked about with the vulcanization of rubber. And that's where we have a link between two of these main polymer chains. Here's another example of cross-linking. Here's the polyvinyl alcohol polymer shown here. And you can see that these dissolve nicely in water because they can hydrogen bond very well. And what you can do to cross-link polyvinyl alcohol is you can add borax, which is a readily available detergent that you can buy at the supermarket. And then it cross-links these polyvinyl alcohol polymers. This is a neat reaction that you can do at home. And if you take polyvinyl alcohol and react it with borax, you're essentially making slime. So this is a fun reaction that you can do with kids. I've done this one with my daughter before. Just make sure you're not doing this with kids that are young enough to eat it. And that wraps up our lecture on polymers. Please make sure you review the study guide and let me know if you have questions about anything we've covered in this lecture.